This is problem number 5 from Solving Exponential Equations Practice. And what we're trying to do is we're trying to solve for x, and in order to solve for x, the first thing that we have to do is we need to isolate. So we're going to divide both sides by 15. And when we do, 645 divided by 15 is 43, I think I'll just type it in the calculator real quick and see. 645 divided by 15. Yes. And now that we've got it in this format, what we can do is we can put in a natural log. And one of the reasons that we're using a natural log is because there's an e in this problem. So it's going to be the natural log of e to the negative x equals the natural log of 43. And consistent with our other problems on our practice here, we've had to use our power property to bring that x out front. In this case, it's going to be negative x natural log of e equals natural log of 43. And yet again, hopefully by now, if you've been going through all your practice, you know that the natural log of e is actually 1. And you probably don't need to write that step. Equals the natural log of 43. Well, negative x times 1 is negative x equals our natural log of 43. And we don't really care what negative x equals. We want to know what does positive x equal. And if you need to, you can put that 1 in there. But we're going to divide. We're going to divide by negative 1 here. We're going to divide by negative 1 there. And then we end up with x equals negative the natural log of 43, which is our exact answer. And we can type it in for our approximate answer. So negative natural log of 43 gives us this value here of negative 3.7612. Again, looking at the 0 to determine that that 2 is going to remain the same. And our intersection point, I will show you how to do that on the calculator again. And what we do is we go into the y equals, and we're going to type in 15 e, second ln, e to the negative x, into our first function, and then we can type in the 645 into the second function. And remember, when we draw that picture there, we're only going to see what we see. Just that part there. We need to change the window on this one. And I changed the y minimum to, I just went a little bit below. I changed it to -2. I went the maximum, I went to 1,000. And you don't have to use the same values as me. And then I went in increments of 50. Just enough so that we can see where this graph intersects. Now that we see that, we're going to go to second and trace. That gets us up to calculate. Number 5, the intersect. And then I'm going to scroll until I'm a little bit closer to where they intersect. I'm going to go here and enter. When it jumps over, I tend to leave it wherever it lands on that second curve. I'm going to press enter. And then the third one is our guess, and we enter. And that's going to give us our value. And sure enough, if you've been paying attention, you see that pattern here, which means that our intersection is the negative 3.7612, and then it's 645. Number 6. Nice thing about this one is that it's already isolated. We can't divide anything, So when we start, we're going to insert our logarithm and going to put in the logarithm here. And we've got 15 and 2x minus 3. And then we've got our 245. Well, we've got an exponent within our logarithm, so we're going to take that exponent. It's the entire value. We're going to write that out in front. This is going to be 2x minus 3. And then it's going to be log 15. I want to put parentheses around that because it's the entire value. 2x minus 3 times log of 15 equals our log of 245. And now what's going to happen is we're going to distribute the log of 15 over the 2x and over the 3. It's just going to be this, and this, this, and this. So it's going to be 2x log 15 minus 3 log 15 equals, and let me sweep this box down a little bit, equals log 245. Well, our goal here is to solve for x, so we need to get the x term by itself. So we're going to add 3 log 15 to both sides. And what happens now is that our 2x log 15. So over here on the left side, and we have log 245 plus 3 log 15. And again, what we want to do is we want to solve for x. Well, if you think about this, what this means over there on the left side is it means 2 times x times log of 15. Well, we want x by itself. And it's 2 multiplied by x multiplied by log of 15. So we can divide by 2 log of 15. And we can divide by 2 log of 15. And what we get x equals log 245 plus 3 log of 15 divided by 2 log of 15. And that's our exact answer. I'm not going to fit that into my box there, so I'm going to write exact right there beside there for you. If we want to know the approximate value, we're going to go back to here. You don't have to have a fraction button to do this problem, but if you do, it's probably a little bit easier. Without the fraction button, it's going to be parentheses. Log 245, close that parentheses, plus 3 log 15, close, and then second closure, divided by another parentheses, 2 log 15, close that parentheses, and then the other one. And that's going to give us our our approximate value, which is the 2.515. Let me label that here. So here's, it's going to be 2.5157. We look at the 2 to determine what that 7 is going to become. It's going to stay the same. So there's our approximate. And then finally, what we want to know is that intersection point. And our intersection point is the 2.5157 And then on the other side, it's going to be the 245. Have to change your y values again to be able to see, although if you still have them in from problem number 5, you probably can see this picture on your calculator screen. Number 7. 4 to the 3x equals 6 to the x minus 2. And again, these are both isolated already, so we can just start right in. And we're going to put a log 4 to the 3x equals log of 6 to the x minus 2. Next, we need to deal with these exponents here. The 3x and the x minus 2. We're going to bring the 3x out in front of the logarithm. We're going to bring the x minus 2, and that's the entire value, so I'm going to put that in parentheses. X minus 2 times the log of 6. And on the right side of this equation, we're going to distribute the log of 6. Log of 6 times x and log of 6 times 2. We have 3x times log of 4 equals x log 6 minus 2 log 6. And eventually what we're trying to do is we're trying to solve for x. So we need to put all of the x terms on the same side of the equals and subtract x log 6. And we do 3x log of 4 minus x log of 6 equals negative 2 log 6. And then what we have to do is we need to isolate the x. And the way that we isolate x is we're going to factor out the x. Factor out the x, we're left with 3 log 4 minus log of 6 in our parentheses. And that still equals negative 2 log 6. It's x times that parentheses, so we're going to undo that by dividing. We're going to divide by 3 log 4 minus log 6. And over here, 3 log 4 minus log 6. So ultimately what we end up with here, here's our exact value, which I, again, won't be able to fit into there very well, but actually I might try it. Negative 2 log 6 divided by 3 log 4 minus log 6. So then we want to know what our approximate value is. Again, if you have a fraction button on your calculator, I would recommend that you use that. Otherwise, make sure you get enough parentheses in there. I think I will use the fraction button this time since I didn't on the last one. Alpha y equals number 1. And this time, it's, again, sorry, I have to look back at it. Negative 2 log 6. Negative 2 log 6. Close that parentheses. And then down here, 3 log 4. Close the parentheses. Minus log of 6. Close the parentheses. And that gives us that value here. And I want to look, it's 0.51387, we're looking at the 7. And for the first time here on this paper, we need to run that 8 up. So our approximate value is going to be negative 1.513. None. Now, the intersection point is a little bit goofy here in terms of the graph. You're probably best off asking a teacher for help on this one, but I'm going to try it this way. If you come over over here to the y equals, and we type this in. What we're putting in one of them is 4 to the 3x. And then on the second screen, it's going to be 6 to the x minus 2. And when we graph here, that'll work. That's got the stuff in from the other problem, the y value, so I still have in my y's there, -2 to 1,000, scale 50. So it actually shows up here on the screen, which is better than I did originally when I was working on this. And let's see if it works. And it might work and it might not work here, but I cannot tell. I can't get close, and even when I have different windows, a different window on my paper of what I use, but what I ultimately ended up doing is just going here in second and trace to get to calculate, number 5, the intersection, and then I didn't move my cursor very much on the first curve, and I just press enter. And then jumped over here to the red one, and I just leave it there. And then when I guessed, and sure enough, it still works on here, which I struggled getting it to work. I struggled getting the picture even. But here is the screen to allow us to fill in what our point is, which is different. We know what the x value is. It's that -1.5139. But then what we see here, if we go to the 10,000ths, is it's 0.00184. So we're going to make it 0.0018. And lastly, same kind of problem, same kind of process. And we're going to put in a log. Log of 5 to the x minus 2 equals log of 3 to the 2x plus 4. We're going to take our exponents, and we're going to write it out front. Exponents out front. We have x minus 2. Again, that's the entire value. It's going to be multiplied by log of 5. And over here, 2x plus 4. I don't want to write it in red, but 2x plus 4, that entire value is going to be multiplied by log of 3. And we want to distribute the log of 5 over there on the left side of the equation. We want to distribute the log of 3 on the right side of the equation. So we end up with x log 5 minus 2 log 5 equals 2x log 3 plus 4 log 3. What we need to do now is we need to put the x terms on one side, we need to put the logarithmic terms on the other side, and it doesn't really matter which way you go. I'm going to take a couple steps just because you are watching the video and trying to figure out exactly what's happening. So I'm going to subtract the 2x log 3 from both sides. We have x log 5 minus 2x log 3. We still have over here on the left side minus 2 log 5. And on the right side we just have the 4 log 3. So what we have done is we have all of the x's on the same side of the equation, and now what we're going to do is we're going to move this 2 log 5 over here to the other side. So that means that all of the x terms are going to be on the left side, and all of the constant terms are going to be on the right side. We have x log 5 minus 2x log 3 equals 4 log 3 plus 2 log 5 Once again, because there's more than one x on this problem, what we're going to have to do is we're going to have to factor. We factor out an x. And when we factor out an x, we're left with log of 5 minus 2 log of 3 equals 4 log 3 plus 2 log 5. It's x multiplied by what's in that parentheses, so we're going to undo that by dividing. Log of 5 minus 2 log 3 log of 5 minus 2 log of 3. And without writing that again, this part cancels out here. That gives us our x equals, which I will try to fit in to our box here for our exact value. I'm going to make the box bigger so that we can maybe fit it in. Again, 4 log 3 plus 2 log 5 divided by log 5 minus 2 log 3. Now we can type it in. And again, if you've got a fraction button, I recommend using the fraction button. I'm going to try to do it without fraction button this time. Again, that's going to require a fair amount of parentheses, but we can do it. Parentheses. 2 log 5. I'm going to check here, sorry. I'm going to check here. Alright. Let me go back there. 4 log 3. I didn't put the parentheses in. One more time. Parentheses. 4 log 3. Close that parenthesis. Plus 2 log 5. Plus 2 log 5. Close the parentheses. Close it again. Divided by parentheses. And then it's going to be log 5. Log 5. Close the parentheses. Minus 2 log 3. 2 log 3. Close that parentheses and then the second one. And when we hit enter, we should get that value. Which is, when we look here around, going to the 10,000, so we're looking at the 3, which means that that 5 is going to remain the same, or approximate, negative 12.9525. And let's see what happens with our intersection point again. If we type this in, I'm wondering if it will work. Go to y equals. If I leave the same values in that I had for my first value here, but if we type in 5 to the x minus 2 and 3 to the 2x plus 4 in the graph. Oh good, we can still see them. That's good news. I'm going to do the same thing that I did last time, which is second trace, which gets us up to calculate. We're going to go to number 5, intersect. And then I'm going to leave it on there on the first curve. I'm going to leave it on the second curve, and then I'm going to hit enter. Ooh, and of course that it did not work. Calculations are not detecting a slight change. Let me try one more time. If we go back here to our graph, and let's go second and trace, and 5. Again, this may or may not work here, so I'm going to go a little bit closer here, see if that happened, and enter. And then I'm going to leave it there and hit enter. And still not working. Third time's a charm. Go back here to y equals, or clear out of there again. Go back to the graph. I had to change my window a little bit, and what I changed it to is I changed it to negative 20. I had to play around with this a little bit to be able to get it to work. And then I put this in an increment of 2. And then my y values I did negative 2 to 5. Left my scale as 1. So here's our picture there. So we can see it a little bit better. And then keep my fingers crossed. Second trace, 5 is the intersect. I'm going to go, can't tell exactly, but I'm going to go a little bit closer. So I'm going to scroll here. Somewhere around here, I'm going to hit enter, and it might work and it might not work. So now we're on the second curve. So I'm going up a little ways from there. And let's see if that helps or not. And there's the intersection. So it's way over here, which was hard to see. I had to really sit down and play with that a little bit. But we knew one of the reasons why I changed my x values there is I know that it's going to intersect at negative 12.9525 there, which makes sense over there. And then this number here, 3.537 e to the negative 11, means that there's 10 zeros before the 3. It's 0.0000. 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 5, 3, 7. So for all intents and purposes, what we would say for the intersection point is that it's negative 12.9525, 0.